Alright, we are moving into balancing chemical equations. And one of the skills that we're going to need to know, though, is how to count up the number of atoms we have of each element in order to balance. Now, when we say balance, that means that we're going to have equal on both sides of our chemical equation, equal on both sides of the arrow, and that's going to fulfill the law of conservation of matter. We've already done problems where we were given an actual mass. Well, here, we're getting ready to look at chemical equations with chemical formulas and making sure we can add them up correctly, okay? Other things you're going to get from this besides counting atoms, you're going to hear me start to use proper names and talk about how to name our different compounds and highlighting polyatomic ions, okay? So when we count atoms and ions, in the equation, if there's a plus sign, you're going to add the atoms in between. If there is a coefficient or a subscript, you're going to multiply. Okay, and so our general rule of counting, and we're going to do this for each element. Okay, we are going to first take a coefficient. That's the number we see out in front of the compound. Then we're going to multiply it by the subscript on the element. And then we're going to multiply it by any subscript we see on the parentheses that it might be in. You're going to do that, and then you're going to add it to whatever we see, if we see that element again, okay? And we'll have some examples of that. So I'm going to use some highlighters here to help us out. Alright, so we're going to look at the coefficient out in front. We're going to look at the subscript on the element. And then we're going to look at the subscript on any parentheses that the element might be in. Okay? And again, you would do that each time that you see an element and then add it together. Okay? And I know you're like, what on earth are you talking about? Well, let's just go ahead and take a look here. For nitrogen, my coefficient, I don't see a coefficient out in front here. Again, it would be right here. And so my coefficient is going to be 1 for nitrogen times the subscript. I don't see one, and let me zoom way in for you. There is not a subscript right after the N, and so that's an implied 1. And then there are no parentheses, so we would keep it a 1. So again, there's the coefficient out in front. Here's the subscript. And since there are no parentheses, we put a 1. And so we have 1 nitrogen. Let's do that again for hydrogen. Our coefficient was a 1, right? Times, I see a subscript of 4, times no parentheses, so 1. And I see it again. And I see it again. Same coefficient of 1. This time the subscript right here is 1. And there's no parentheses, so it's 1. So again, let's make sure we see what we're doing here. There's our coefficient. I should just leave these open, shouldn't I? We have our subscript of 4. That's where we see that. And then no parentheses, so 1. On our second H, we had a coefficient of 1 still out in front, a subscript of 1, and no parentheses, so an implied 1. Alright, so now let's add these up. I've got 1 times 4 times 1 is 4, plus 1 is 5 total. And again, y'all, I'm breaking this way down for us. We're gonna end up doing things a little bit quicker. And then our oxygen, I still see a coefficient of 1 out in front times a subscript on oxygen of 1, no parentheses, so times 1, and that's 1 oxygen. Okay? You can't see that. Let's take a look at the next one. Okay? I still don't have a coefficient, do I? So it's an implied 1. That means it's going to be a 1 for all of them, right? The coefficient goes for everything that follows it. Okay? Next, for my nitrogen, I see a subscript of 1. I don't see a subscript, so it's a 1. Again, we're looking at the subscript right after the capital letter, right after that element symbol, and so there's nothing written right after the N. This 4 goes just for the hydrogen, so nothing for the N. And then, is this nitrogen inside of parentheses? Well, it is, and the subscript outside the parentheses is a 3. So let me make sure I highlight this for us. That's where that 3 is coming from, right there. Okay, and so now I have 1 times 1 times 3, which is 3 nitrogen. For hydrogen, we had that coefficient of 1. I have a subscript of 4 on the H, and then I have a subscript of 3 on the parentheses that the H is in. So 1 times 4 times 3 is 12. Our P, start at the beginning. I have a subscript, or I have a coefficient of 1. Let me zoom out for us. On the P, there's no number right after it, so it's a subscript of 1 on the P, and it is not in parentheses, so it's a 1. That's 3. And for our oxygen, I see a coefficient still of 1 times a subscript of 4 on the oxygen, and it's not in parentheses, so a 1. So 1 times 4 times 1 is 4. Let's take a look here at our next one, which is glucose. I do have a coefficient right here, don't I? Okay, I have some subscripts. Do I have any parentheses? No parentheses. Okay, so if I look at carbon, I'm going to see 3 times 6 times 1. 3 times 6 is 18. Hydrogen, 3 times 12 times 1, because there's no parentheses, is going to be 36. Oxygen, 3 times 6 times no parentheses, which is 1, 18. Now, we're going to need to start picking this up a little bit more so that it's not quite as slow for us. But on these examples here, I'm going to do my best to show you some work here. Here, it just wants to know about the oxygens. Okay, so I see an oxygen here. Out in front, I see a coefficient of 7 times 1 on the oxygen times 1 parenthesis, no parentheses. And I see another oxygen here, so 5 times a coefficient, a subscript of 2, sorry, times parentheses, no parentheses, so that's a 1. So 7 plus 5 times 2 is 10. 7 plus 10 is 17. There's a total of 17 oxygens there. On this next one, it says hydroxide ions. Well, what is the symbol for hydroxide? Oh yeah, you know it. Hydroxide is OH negative. It's one of our polyatomic ions. So I'm looking at the OHs. So I'm looking at this right here. What's inside of the parentheses, okay? So it's not a single element there. but my coefficient is still 1 times, I'm not looking at a single element, I am looking at the coefficient outside. So 1 times 3 is 3 hydroxides. Sulfate, ATE, tells me that it's a polyatomic ending in oxygen. So if I take a look, I see this polyatomic right there, SO4. I didn't have parentheses written there, but I'm going to go ahead and put some in. And so now I'm going to look at my coefficient. That's 1 out in front times not a single element, so times the subscript on the outside of the parentheses, which is an implied 1. And so there's only one sulfate ion. Notice that when I found that polyatomic, I went ahead and put parentheses around it to kind of isolate it in its own little bubble. That helps me see it as one big chunk rather than each individual element. And you can balance by looking at elements, or you can actually balance by looking at different chunks as long as they're the same. Okay, we're going to do a whole lot more practice on this tomorrow in class. So come in ready for some questions, and we're going to be doing some more practice and then working on polyatomic ions. Now, do you see any other polyatomics up here? If I see multiple capital letters together, like more than 2, I'm going to think there's a polyatomic. And if I look here, I see NH4. Well, if it has a plus charge on it, that's ammonium. And then, oh yeah, I've got a polyatomic there, OH, which is hydroxide. So this is ammonium hydroxide. This one right here, I see that NH4, again NH4 plus is ammonium, and PO4 with a 3- charge is phosphate. So this is ammonium phosphate. Okay. Down here, this would be considered iron 3 hydroxide, and we were looking at sodium sulfate in our practice. Again, I'm trying to preview a few things for you on that. Don't freak out if you're like, how does she know how to name those? Okay, we'll get there in about a week and a half.